Hello dear students, welcome to Konar classes. Today we are going to start a new chapter called Sequences and Series. So we will have several lecture sessions here. So let's start with the first one. And here we are going to discuss what is sequence, what is series, and then we will start discussing arithmetic progression and how to find arithmetic means and all these things. So let us first understand what is a sequence. If you see, the sequence is an English word. What about the meaning is there in the English word for the sequence? The same meaning here in context of mathematics. Let me give you an example. Okay, think about that the population growth of human being or the population growth of bacteria is done in such a way that you can identify the first term, then you can identify the second term, then you can identify the third term, and so on. It goes in that manner, and we define this as a sequence. For example, that suppose the growth in the first day is a1, and then in the second day it is a2, in the third day it is a3. Then we can say that a1, a2, a3 ... that is in a sequence. Okay, like that there are the amount of money you are depositing in a bank. Okay, that is also a sequence. Yes, sometimes we can find a pattern in that sequence and sometimes we can't, but whatever the activities where you can identify what is the first term, then you can identify what is the second term, then you can identify what is the third term. In that way, when it proceeds, then we can call it as a sequence. Okay, when the number of terms in that sequence is a finite number, we call it as a finite sequence, and whenever the number of terms in that sequence is infinite, okay, then we call it as an infinite sequence. So let us understand by means of an example, two examples, one from finite, one from infinite. Think about, there is a generation gap of 30 years. Okay, one generation, and for the next generation there is a gap. We are assuming it is a 30 years gap. Okay, now we need to find the number of parents, then the grandparents, the great grandparents over the period of 300 years. That means what? So if we see that 300 years we have and there is a generation gap of 30, that means how many generations we are going to get? There are 10 generations. Okay, so in the first generation, if we have 2 members, and in the second generation if we have 4 members, in the third generation if we have 8 members, in that way if you go up to the 10th generation, you will get, in that sequence you will get 1, 0, 2, 4 members. Okay, so how we define? We defined that that the first term, that 2, that is we defined as a 1. Okay, then 4, the second term we defined as a 2. Then the third term 8 we defined as a 3, and so on it goes on, and we define the 10th term as a 10. Okay, so now let's look into another sequence which is not a finite sequence. Okay, what is that? For example, that we are dividing the number 10 divided by 3. When you are dividing that number 10 by 3, whatever the quotient we are getting, that we are writing in a sequence. So what you will get first? So first we will get 3, and here you will get 9, and if we subtract we get 1. So what is the first term we are getting? The first quotient we are getting is 3. Then what happens, dear students, is that we put one decimal point and we get 0, then we get 3, and again we get 9. Okay, so we get 1 here. So the next quotient we are getting is that 3.3. The next quotient what we will get is that 3.33. In that way it will continue. Okay, So now if we define this as the first term, that is A1, this as the second term, that is 3.3 as A2, and 3.33 that we defined as A3, and so on. Okay, and this is an infinite sequence because the number of elements in the sequence is not finite. Whereas in the previous example, okay, on the generation gap, when we are finding the number of ancestors, okay, there we find it is a finite one because we go up to 300 years of the generation with a generation gap of 30 years. Now, dear students, that in most of the cases we are able to find there is a pattern to find a sequence, okay, and sometimes we can't get the sequence, that in the pattern to find the sequence. Think about that we are going to find the set of all even numbers, okay. If we want to find the set of all even numbers, then how we are going to get it? Okay, so the first number is 2, then the next number is 4, the next number is 6, the next number is 8, and it goes on. So if we see, if we define this as the first term, that is A1, then how we are going to get the 4, that is A2. A2 is nothing but 2 into, 2 into 2, that is 4, right? And how we are going to get A1, that is 2, that is 2 into 1. Then the next even number 6, how we are getting A3, that is nothing but 2 into 3. The next term is A4, how we are going to get, that is equal to 2 into 4. So if you see, dear students, that whenever we are getting A1, A2, A3, A4 in that way, that we are multiplying 2 into that. For A1 it is 1, for A2 it is 2, for A3 it is 3, for A4 it is 4, so it is multiplied by 2. Then in that way, if we go to the nth term, that is, if we write that nth term is An, how we are going to get that An? An we are going to get 2 into n. So this is the way we can define a sequence, that An is equal to 2 into n. A1 is 2 into 1, A2 is 2 into 2, A3 is 2 into 3. In that way we can find the sequence of all even numbers. In that way, in the similar manner, we can find the sequence of all odd numbers as well. How? The first odd number is 1. The second one is 3. The next one is 5. The next one is 7. And in that way it will continue. So how we are going to get it? So A1, here this is the first term, okay, and then we get the 3, that is the second term. So how we are going to get it? So that is equal to, we are going to get that 2 into 1 minus 1, okay. So 3, how we are going to get A2? So that is equal to 2 into 2 minus 1. Then A3, how we are going to get A3? A3 we are going to get that 2 into 3 minus 1. So what we are seeing, dear students, that the nth term An we are going to get is that 2 into n minus 1, okay, where n is a natural number. In that way we are going to get the set of all odd numbers. So here we get the set of all even numbers, set, or we can write sequence of even numbers, and here we are getting the sequence of odd numbers. We get sequence of odd numbers. Now, as I was telling few minutes back, that in most of the cases you will able to define a proper equation to find the different terms of the sequence, and sometime you may not. For example, the set of all prime numbers, okay. If you want to define the sequence of prime numbers, you cannot find a defined equation to represent different terms of that sequence, of these prime numbers, right? Now, there are sequences where you need to define in a recursive manner. How? Let me give you an example. Okay. Suppose you get a sequence something like this, that 1, then 1, then 2, then 3, then 5, then 8, and so on. So if you look into it, you are not able to directly find a pattern, okay? But if we look it very minutely, we will find a recursive pattern. So this is A1 and this is A2. A1 is 1, A2 is also 1. What is A3? A3 is 2, A4 is 3, A5 is 5, A6 is 8, and so on. So how we define? We define that A1 is equal to 1. Okay, and what we are defining A2 is also equal to 1, and what we are getting A3 is equal to A2 plus A1. You see that A3, which is 2, that is nothing but the sum of the previous two terms. Okay, then we get A4. What is A4? A4 is equal to A3 plus A2. A3 plus A2. In that way, we are able to find a pattern. What is that pattern, dear students? So that is AN is equal to AN minus 1 plus AN minus 2 for all n belongs to the set of natural numbers, and n is greater than 2. That means you should start with n equal to 3. And this is known as the Fibonacci sequence. Okay, so this is known as Fibonacci sequence, where the definition of to get the terms of the sequence is obtained by means of recursion. That means what? To find a term of that sequence, we need to depend on the previous terms. Hence, it is known as the recursion. Okay, dear students. So now, let's solve couple of questions and then we'll proceed. Okay. Okay. One more point before we proceed to solving a couple of questions. So let us understand what is series. So far we discussed in brief about sequence. So now let us understand what is series. A series is nothing but when you represent the different terms of that concerned sequence with a plus sign. What is meant by that? Suppose you have a sequence. So I am writing it here, sequence. The sequence is something like this. A1 is the first term, A2 is the second term, A3 is the third term. In that way, you go up to the nth term and it can proceed after that. Now, what is the series? The series corresponding to this sequence is nothing but a representation. Its representation is something like this: A1 plus A2 plus A3. In that way, it will continue up to AN, and after that also it can continue depending on how the sequence is actually continued. So the series is nothing but the representation of the different terms of the sequence, and there is a addition symbol. Now there is a fundamental difference between a series and the sum of the series. What is that? Let's consider that we have a series with 4 terms. The 4 terms are 2, 4, 6 and 8. So that means what, dear students? So A1 is 2, A2 is 4, A3 is 6 and A4 is 8. So it is a finite sequence. And what is the series? Series is that, so if we write the sequence is A1, comma A2, comma A3, comma A4. Okay, and what is the series? Series is a symbolic representation A1 plus A2 plus A3 plus A4. Okay, that means what? It is 2 plus 4 plus 6 plus 8. That means we can write it is 2 plus 4 plus 6 plus 8. Now, if it is the next term, that is the sum of the series. Sum of the series. Okay, so sum of the series will be what? It is the addition of all these terms. Okay, so that means what? It is 20. 2 4 plus 4 plus 6 plus 8, that is equal to 20. So sum of the series will become 20. So these are the fundamental differences of different terminologies, that is sequence, series, sum of the series, like this. Okay, so now let's work on a few questions quickly. So the first question. So let me write down the first question, and after that we will solve together. Okay, so here is the question. Write the first three terms in each of the following sequence defined the following. Okay, so the first one is that an is equal to 2n plus 5, and that is the first part of the question. And second part of the question is that an is equal to n minus 3 by 4. The question is that we need to find the first three terms of this sequences. Okay, for the first sequence, if we find that an equal to 2n plus 5, quite simple. So you need to find a1. What will be a1? a1 will be 2 into 1 plus 5. So that is equal to 7. What will be a2? a2 will be, instead of n we should write 2. So that means 2 into 2 plus 5. That is equal to 9. Then it is coming a3. That is 2 into 3 plus 5. That is equal to 11. So what are the the terms we are getting? 7, 9 and 11, the first three terms. Now let's look into the second one, that an equal to n minus 3 by 4. So let me use a different color. So if we find that an equal to n minus 3 by 4, so what will be the a1? a1 will be 1 minus 3 by 4, that is equal to minus 2 by 4, that is equal to minus 1 by 2. What will be a2? a2 will be 2 minus 3 by 4. Instead of n we are writing 2. So that is equal to minus 1 by 4. What will be a3, dear students? a3 will be 3 minus 3 divided by 4, that is 0 by 4, that is equal to 0. So these are the first three terms. The first term is minus 1 by 2, second term is minus 1 by 4, and third term is 0. Okay, so now let's proceed to the next question. Okay. So now if we proceed to the next question, so let me first write down the question. the question number 2. The question is that what is the 20th term of the sequence? What is the 20th term? 20th term of the sequence defined by an equal to n minus 1 into n2 minus n into 3 plus n. So the question is that we need to find the 20th term of this sequence. Okay, so that means what? We need to apply n equal to 20. If we apply n equal to 20, we get the 20th term A20. That is equal to what, dear students? That is 20 minus 1, then 2 minus 20, and then we write 3 plus 20. So 20 minus 1, that is equal to 19, into 2 minus 20, that is equal to minus 18, into 3 plus 20 is 23. Now if we compute these three terms, we will get the value minus 7866, and that is the 20th term of this sequence, whose definition is given as an equal to n minus 1 into 2 minus n into 3 plus n. Okay, so now let's proceed to the next question, dear students. So question number 3. So let me take the question from the notebook. So third question. Let the sequence an is defined as, let the sequence an be defined as, how it is defined? A1, that is the first term, that is equal to 1, and an is equal to an minus 1 plus 2. That means the nth term is n minus 1th term plus 2. And what is the question? Find the first 5 terms and write the corresponding series. The question is that find first 5 terms, and write corresponding series, and write corresponding series. Okay, so one thing, dear students, so we find that a1 is equal to 1, correct? So that is the first term. First term we know it is 1, so a1 is equal to 1. That is done. Okay, now we are going to find that second term, a2. So a2 should be equal to what? a2 minus 1, that is a1 plus 2. And what is the value of a1 we got, dear students? 1. So from here we can write 1 plus 2. So that implies what we get the value of a2, dear students? The value of a2 we get as 3. Correct? Now let's proceed to find the third term. What is that? That is equal to a3. a3 should be equal to what? A of 3 minus 1, that is a2 plus 2. a2 plus 2. What is the value of A2? The value of A2 you obtained in the previous step, that is 3. So 3 plus 2. So from here we get the value of A3 as 5. Correct? Now let's proceed to find the fourth term. Fourth term is A4. What is A4, dear students? So A4 is equal to, according to this definition, recursive definition, A4 is equal to A4 minus 1, that is A3 plus 2. So that is equal to A3 plus 2. And the value of A3 we obtained in the previous step as 5. So that is 5 plus 2. So we get the value of A4 is equal to 7. Correct, dear students? Okay, now let's find the value of the fifth term, that is A5. So what is A5? A5 is equal to A4 plus 2, and the value of A4 we obtained as in the previous step as 7. So 7 plus 2. So from here we get that A5 is equal to 9. So dear students, so these are the different terms. 1, 3, 5, 7 and 9 are the first 5 terms of that sequence. Now what is the second part of the question? Write corresponding series. If we need to write the corresponding series, the series will be written something like this. That the first term, that is 1, plus second term, it is 3, plus the third term, that is 5, plus fourth term, that is 7, and then fifth term, that is 9. So that is the corresponding series. Okay, dear students, so this is the series 1 plus 3 plus 5 plus 7 plus 9. Okay. In fact, it will continue after that. Okay. So after that it will continue. So that is the way we define the series. Okay. Now, dear students, so we proceed to the next question. Okay. Okay. So next point, what we are going to discuss is very important. That is the, we are now starting the most important part, that is called the arithmetic progression. Okay. So let us understand what is arithmetic progression. If you recall, dear students, that when I was discussing about sequence, that I told that if we find a pattern in that sequence, then we can formulate that sequence. That means we can express the different terms of that sequence by means of a formula. Okay. Now, arithmetic progression is one such. What is that? Arithmetic progression, let me first write it down. That arithmetic progression. Arithmetic progression is such that we have a sequence. Okay. What is that sequence? The sequence is that A1 first term, then A2, then A3. In that way it will continue and we get AN, the nth term, and so on. I repeat once more, dear students. So suppose this is a sequence. The first term is A1, second term is A2, third term is A3. In that way nth term is AN, and so on, such that the difference between the consecutive terms is always constant. What does it mean? It means that whatever the difference between A2 and A1 we represent as A2 minus A1, that should be equal to the difference between A3 and A2. That means A3 minus A2. That should be equal to the difference between A4 minus A3. And in that way it will continue, and that should also be equal to the difference between AN minus AN minus 1. That means that nth term minus the n minus 1th term. Okay. If a sequence follow this pattern, what is the pattern? the difference between the two consecutive terms is a constant, we can say that sequence is in arithmetic progression. Now that difference what you see now, dear students, generally the difference is denoted by D, okay, and that D has a specific name and its name is common difference. It is called common difference. And the first term, which is denoted by A1, okay, so that is known as first term, but it has a specific, symbolic representation. The symbolic representation is called the A. So A we defined as the first term. First term. So dear students, in a arithmetic progression there are two important terms. The first one is known as the first term, that is denoted by A, and the second one is D, denoted by D, and its name is common difference. If we know the first term and the common difference, we can construct that arithmetic progression. How? Suppose we have a arithmetic progression whose first term is A and common difference is D. Then how we are going to construct that arithmetic progression? The first term is A, so A. Second term should be A plus D, because we know the difference between two consecutive terms is D, the common difference. Then the third term will be A plus 2D, correct? And in that way it will continue, and the nth term will be A plus n minus 1 into D. And after that nth term it will again continue. Look at, the first term is A, second term is A plus D, third term is A plus 2D. In that way we get the nth term as A plus n minus 1 into D. Okay. So if you see the difference between two consecutive terms, that is A and A plus D, it is D. That is A plus D minus A. The difference between second term and third term, that is also D. How come? A plus 2D minus A plus D, that is D. In that way if you proceed, you will always find the difference between two consecutive terms is D, the common difference. So from here what we get, dear students? That the nth term, that is a very important one, the nth term is denoted by Tn. Generally it is denoted by Tn. And what is that? Its value is A plus n minus 1 into D. That means if we know the first term and the common difference, as I was telling, if we know the first term and common difference, we can construct that arithmetic progression uniquely, and also we can find what is the nth term. Nth term is A plus n minus 1 into D. Okay. So now the second one is that what is the sum up to first n terms. Okay. So sum up to the first n terms. Sum up to the first n terms, and that is denoted by Sn, capital Sn. Okay, so how it is symbolically represented? So Sn is nothing but the first term plus second term plus third term, in that way up to nth term. That means what is that? By the way, Tn and An in this context are same. So Sn should be what? So if we write Sn, so Sn is equal to the first term, that is T1, plus second term, that is T2, plus third term, plus is T3. In that way we go up to the nth term in Tn. So what it will be? So there is a formula for that, dear students. So Sn is equal to n by 2, then 2 into A plus n minus 1 into D. that is the sum up to the first n terms. Okay. So what is that? That sum up to the first n terms of an arithmetic progression is denoted by Sn, and its formula is Sn equal to n by 2. That means how many terms are there, you divide by 2 into 2 into a means 2 into the first term plus n minus 1, that means number of terms minus 1 into d, the common difference. Okay dear students, so now this particular formula, that Sn, that can be represented by means of the last term as well. How? Let me show you. So dear students, so let me use a different color. So as you see that we write Sn something like this. So from here we can write what? We can write Sn is equal to n by 2. Let me write in the next line. Okay. So what we can write, dear students, that Sn we can write that is equal to n by 2 twice a plus n minus 1 into d. So that we are writing a plus n minus 1 into d. Correct? Instead of 2a plus n minus 1 into d, we are writing a plus n minus 1 into d. Now if you look at a plus n minus 1 into d, what it is? That a plus n minus 1 into d, that is nothing but the nth term. So now if we want to find the sum up to the first n terms of an arithmetic progression, then Tn is nothing but a plus n minus 1 into d, that is nothing but the last term when we consider up to the n terms. That Tn is nothing but the last term. Last term is generally denoted by L. So that is denoted by L. So what we get the formula for Sn, dear students, that we get the formula for Sn as n by 2 into a plus L, where L is the last term of that arithmetic progression. Okay dear students, so far we are able to find that the nth term, that is a plus n minus 1 into d, the sum up to the first n terms Sn, that is equal to n by 2 into twice a plus n minus 1 into d, and the sum of the first n terms expressed in some different way in terms of the first term and last term as n by 2 into a plus L. Okay dear students, so now what we are going to discuss is that arithmetic mean. After that we will solve few questions. Okay. So these are important formulas, and while solving the questions we will see these formulas are being used. Okay. So now we are going to discuss about arithmetic mean. Arithmetic mean. So let us understand what is arithmetic mean. So dear students, let us consider there are two numbers. One number is A and another number is B. Now these two numbers are any two numbers, we can always say they are in arithmetic progression. Okay, because their difference is B minus A. Okay. As there is no third terms, we are not able to verify the common difference is actually validate with the second term and third term or not. Now, if we have just these two numbers A and B, the point is that can we insert a number here between A and B such that when we consider that third number, that means suppose here we are writing a number called M, then we get A, M and B are in arithmetic progression. Let me repeat once more. We have two numbers A and B. The point is that can we insert a number which is greater than A and less than B? Between means in between A and B, if we can insert a number M such that the three numbers now, that A, comma M, comma B are in AP. Are in AP, then we can say yes, that M is the arithmetic mean between A and B. How to find? Quite simple. We know from the properties of arithmetic progression the difference between M and A, that is M minus A, is equal to the difference between B and M, that is B minus M, and that is known as common difference. No? So from here what we get? So from here we get the value of M is equal to A plus B by 2. So dear students, what we get? We get is that, what we get is something like this, that we have the number A and B, and in between we are able to insert a number A plus B by 2. So the three numbers now are A plus B by 2 and B. And these three numbers are in arithmetic progression. Now the question is, if any two numbers are given, can we insert n arithmetic means? What does it mean? First, let me write it down. Okay? So inserting n arithmetic means between A and B, that we are going to discuss now. Sorry. Okay? So inserting n arithmetic means between A and B. I can write it here, inserting n arithmetic means between A and B. A and B are two numbers, and we are going to insert n arithmetic means. How we are going to do that, we are going to see it here. Okay? We will derive here. Very simple. Just follow this statement. You also do along with me. Pause the video, proceed, and in that way you will have a very good exposure. So what we have? We have the first number A here and the second number B here. What is our task? Our task is to insert n arithmetic means between A and B. That means first number is A, then we insert one arithmetic mean M1, then another arithmetic mean M2, then another arithmetic mean M3. In that way we continue till that n arithmetic means Mn. Correct? So that means what? That A1, M1, M2, M3, sorry, A, M1, M2, M3, Mn, Mn, B, they are in arithmetic progression. So this is an arithmetic progression in which there are n plus 2 terms, the two extreme terms A and B, and in between there are n arithmetic means. That means n plus 1, n plus 1 plus 1, n plus 2 terms. That means what? That B, the last number, that is nothing but the n plus 2th term of this arithmetic progression. That is nothing but n plus 2th term of this arithmetic progression is denoted by AP as well. So from here what we get? That B is equal to, if you recall, what is the nth term? Tn is equal to A plus n minus 1 into D, where D is the common difference and A is the first term. So here first term is A plus, in case here it will be, in this case it will be n plus 2 minus 1, n plus 2 minus 1 into D, where D is the common difference of this arithmetic progression. So what we get, dear students, from here we get B is equal to A plus n plus 1 into D. Only D is unknown here, correct or not? D is only unknown. So from here what we get, the value of D? The value of D we get B minus A divided by n plus 1. That is the value of D. And it's a very important derivation. Okay? Why it is an important derivation? Because this will help us to find all these n arithmetic means. Okay, so how to find the value of m1? We find the value of m1 is equal to, a plus, 1 into d, a plus 1 into d. That means what? A plus 1 into d. D is b minus a by n plus 1. B minus a by n plus 1. Correct? Now we can find the value of m2. m2 will be what? A plus 2 into d. That is equal to a plus 2 into b minus a divided by n plus 1. Correct? That is the m2, the second arithmetic means. In that way, if we proceed, then suppose mk we need to find the kth arithmetic mean. That should be what? A plus, k into d. A plus k into d. That is equal to what? A plus k into b minus a divided by n plus 1. Correct? And in that way, if we proceed, what we get? The last arithmetic mean, that is mn, that is nothing but a plus, we get this is the n plus 1th term, so a plus n into d, that is equal to a plus n into b minus a divided by n plus 1. But what is important? Important is that the kth arithmetic mean, that is mk. The kth arithmetic mean is equal to a plus k into b minus a divided by n plus 1. Now you need to vary k from 1 to n. Okay, if you vary k from 1 to n, you are going to get the first arithmetic mean up to the nth arithmetic mean. The rest of the values you are aware of. A you are aware of, that is the first term. B you are aware of, that is the last term. N you are aware of, that how many arithmetic means you need to insert. Okay, so let us solve one question and it will have our understanding absolutely clear. Okay, so the question here is that, let me find it out. Yeah. So let me write it down here. Okay. The question here is, insert 6 arithmetic means between 3 and 24. So let me write it down. Insert insert 6 arithmetic means between 3 and 24 such that 3 and 24. The same question can be represented like this, that insert 6 numbers between 3 and 24 such that the resulting sequence is in arithmetic progression. The same question can be given in that manner as well. So if we look into this question, dear students, so what is A? We need to find from this problem statement, we need to find the value of A. What is A? A is equal to 3. What is B? B is equal to 24. And what is N? N is equal to 6. N is equal to 6. So now we need to insert 6 arithmetic means. That means M1, sometimes the arithmetic means also described as A1, A2 also. Okay, here we define M, but you can define A1, A2, A3 up to AN also. Okay. So for example, if we describe in terms of A, then how we can do is that A here and B here. In between we have A1, A2, A3, A4, A5 and A6, and then finally B. Correct? So here our task is to find the value of A1, A2, A3, A4, A5, A6. And when I write MK na, that is also you can define as AK. Correct? That is also a symbolic representation. So what is the value of AK? AK is equal to A plus K into B minus A divided by N plus 1. So in context to our particular example, the value of AK is equal to A. A is what? 3 plus K into B minus A. B minus A is 24 minus 3, that is 21. So you can write 21 into K divided by N plus 1, that is 6 plus 1 is 7. So from here what we get? We get the value of AK is equal to 3 plus 3K. 3 plus 3K. So from here we can further simplify and we can write AK is equal to, we can take 3 common, 3 into K plus 1. Now it is quite simple to find all these 6 arithmetic means. How we can find it out? Let us first find the value of A1. What will be A1? A1 will be K equal to 1, so 3 into 1 plus 1, that means 3 into 2, that is equal to 6. Correct? What will be the value of A2? A2 will be 3 into 2 plus 1, that is 3. 3 into 3, that is 9. Then we get the value of A3. A3 will be what? 3 into 3 plus 1, that is 4. That is equal to 12. Then we get A4. What is A4, dear students? A4 is equal to 3 into 4 plus 1, that is 3 into 5. 3 into 5, that is equal to 15. And then what is A5? A5. A5 is equal to 3 into 5 plus 1, that is 6. That is equal to 18. And then finally we can get the value of A6, that is 3 into 6 plus 1, 7, that is equal to 21. So what are all these 6 arithmetic means? The first arithmetic mean is 6. The second arithmetic means is 9. The third arithmetic mean is 12. The fourth arithmetic mean is 15. The fifth arithmetic mean is 18. Okay, and the sixth arithmetic mean is 21. Okay, so with this note, let me conclude the class here. So in the next session, we will solve some questions on arithmetic progression. Thank you very much. Take care. Bye.